difference of two squares is when you're trying to factorise a quadratic when the x term, the middle term, is missing. So what we mean by the difference of two squares is, for example, a quadratic like x squared, there'll be no middle term, but it'll be a difference, i.e. there'll be a minus, and then there'll be a number that's generally a square number. So it won't be 18 or 20, it'll be a number that you can square root easily without ending up being a decimal. So something like x squared minus 25. And to unpack this and to realise what's really going on, you have to recognise that really a quadratic has an x term. Most of the time there will be a middle term, i.e. the term just with x. If it's not there, well, it kind of is. It's just there's zero lots of x. So really that's x squared, let's get another colour, plus 0x and minus 25. And if we apply the same principle as before, we'll say we need two numbers that add up to make the middle number, i.e. the middle number in front of x, which is just 0. So I need two numbers that add up to make 0. And we need two numbers that multiply to make the last number. The last number is not 25. Okay, the last number is minus 24. Remember, you've always got to look at the number in the middle or at the end. Okay, the plus and the times respectively with the sign. The last number is minus 25. But how can we make two numbers that add up to make 0 or times to make minus 25? Well, the only way you can add up to make 0 is having two numbers the same, one with the plus, one with the minus. Because when you add a number and then take it away again, you get back to where you started. So in this case, the numbers that will work is plus 5 and minus 5. Again, you might say, well, 6 and minus 6 also add up to 0. 7 and minus 7. In fact, any number, plus or minus, will add up to make 0. But in particular, they must multiply to make minus 25. So the only pair of numbers that would work is 5 and minus 5. Which means that the factorisation of x squared minus 25 is x plus 5 and x minus 5. X plus 5, x minus 5. Now, it goes a bit further than that, and it says, well, 5 and minus 5, they're connected to this number on the end, the 25. Think about it, they have to multiply, the 5s have to multiply to make 25. That sounds like we're square rooting. The 25 square roots to 5. And then we put a 5 there and a 5 there. So what we can see is when you have this case known as the difference of two squares, you don't actually have to go through this process. I just did that to show you why it works. It's actually far easier than that. When it's x squared minus a square number, all you have to do is square root the number on the end, which is 5, and then stick it with a plus and stick it with a minus, with an x, and you're done. So what we say is as follows. We say if you've got x squared minus a squared, okay? X squared, missing middle term with a minus, and a squared, just any number squared, the factorisation becomes x plus a, x minus a. Okay? You square root the x squared. Remember, square rooting x squared just removes the squared. So there's a square root operation that goes there. You square it there. You square it there, so that's easy. Square root of x squared just turns into x. We usually do that anyway. Then the a squared, okay, when you square root it, it removes the squared. So it just goes to a. So for example, x squared minus 100 becomes x plus 10, x minus 10. X plus 10, x minus 10. Okay, because square root x squared, that goes to an x, put it there and there. Square root 100 is 10, you put it there and there. One with a plus, one with a minus. That's what this says. Okay, the a squared in this case is 100. And when you square root it, it goes to 10. Be careful. Some people take the 100 and put the 100 here and there. No, this is a. That's a squared. When you go into the factorisation, into the bracket, you have to square root this number. Notice it goes from a squared to a. That is done via square rooting. So, let's just have a quick exercise. I just want to have a go at the following few questions. Okay, it should only take you about a minute because this part here is quite straightforward. So I'd just like to apply this formula very quickly. And then we're going to look at some harder examples. Okay, so have a go at factorising each of these. So factorise each of these into two brackets. Again, just beware with number 3. Number 3, you'll notice the algebraic term is on the end, and that will make a little bit of a difference, so just be careful. So have a go, press pause, and then when you're ready, press play, and let's see if you get them right. So y squared minus 49. So we said all of these fit the form of our formula for difference of two squares. We said the difference of two squares is if you have x squared, of course it doesn't have to be x, there are other, okay, x squared minus a squared becomes x plus a, x minus a. We saw that formula on the previous board. So y squared minus 49, that's a square number minus something else that is squared. So effectively what we do is let's square root the y squared, which just gets rid of the squared, that's y. You put that in the first bracket and the second bracket, square root 49 plus 7 minus 7. So the first answer is y plus 7, y minus 7. And there you see you have the difference of two squares. You can actually multiply this out and you can go back and you can check. It doesn't matter, by the way, if you have y plus 7 first or y minus 7 second, doesn't matter. Right, similarly here, x squared, square root that, so you get x, square root that is 9, plus 9 and minus 9. That's all we're saying here. If it's the difference of two squares, you square root the left, square root the right, okay, and stick them in a bracket, one with a plus, one with a minus. Now here, we have to be careful. The 16 is first. The only difference that makes is that in my bracket, the square root of 16 goes first. Remember, when you square root y squared and you square root x, that goes to y and x. The y's and the x's go first in the front. So this time 16 is first up. So when you square root 16, you get 4. And the 4 goes in the front. So notice the number's here at the back, at the end. That's because the number was at the end. Okay? Now 16 is first, so 4 must go first, not at the end, at the beginning. When you square root m squared, you get m. So you get plus m and minus m. Okay? That's different. That's not the same as m plus 4 and m minus 4. That would be if it was m squared minus 16. m plus 4 is the same as 4 plus m. But 4 minus m and m minus 4, they're minuses of each other. They're not the same thing. Okay? So it's 4 plus m and 4 minus m. So what do we do if there's a number in front of the x squared? That's a little bit of a problem. I can't just square root the x squared and just do like normal, say x, and the square root of the 9, because, well, that doesn't work, because if you multiply that out, hopefully you can see that's x squared minus 9. I've completely ignored the fact there's a 4 there. So what do I do? So in fact, we call this a hard example, but actually it's not really hard. You just have to think about what the process is and apply the process accordingly. So what do? We usually square root the left and square root the right. Stick it in a bracket, one with a plus and one bracket with a minus. It's exactly the same here. When I square root 4x squared, you just have to be careful. Treat them as two separate families. You square root the 4 and then you square root the x squared separately. So let's see. So let's prepare our brackets. So if you square root 4x squared, there's a bit of a double process there. Okay? Square root 4 is 2. Let's put 2 there, and 2. But that's only half of it. When you square root 4, you get 2. And when you square root x squared, remember square rooting in x squared, the square root just gets rid of the squared. So square rooting x squared is just x. So that's x, and that's x. The 9 is the same as before. Right, we know how to square root 9, it's just 3. So one with a plus, and one with a minus. So if you square root a number with an x squared, you remember that you have to square root the number first, then you square root the x squared, which gets rid of the squared, and then you put it together. Okay, it's not just 2, it's not just x, it's everything, it's 2x. So based on that, have a go at these examples, and then we can look at one step even harder than that. Based on that, can you try these two examples? Let's see if you get them right. So again, just always ask yourself, because there are many different categories of quadratics that involve the difference of two squares and other types as well. So this is only applicable if you've got a minus in the middle, there's a missing middle term, and you've got something you can square it on the left, something you can square it on the right. If that was a plus, none of this is valid. If there was a middle term, you've got three terms, again, that's a different category. So, in this case here, you've got the difference of two things that can be square rooted, so let's open up two brackets. Right, we square root this, pop it in the beginning, two spots, you square root this, pop it in the final two spots, and you continue. So, 81y squared, again, there's two things there, you square root both of them and glue them together. So, square root the 81, you get 9, 9, square root the y squared. Remember, again, the square root in the y squared, the square root just kills the squared, as it were. So, square root of y squared goes back to y. Square root of 25 is 5, 1 with a plus, 1 with a minus. Again, in case then if you made this mistake, be careful. The 25 goes to 5 and minus 5. Don't just put 25 here and minus 25 here. Okay? It's a column mistake, but if you do that, you've forgotten to square root. Right, this one here. So this one here means we've got this kind of double action of the square rooting for both the left-hand side and the right-hand side. So in other words, let's open up a pair of brackets. 36x squared, again, similar to what we saw before, that would be 6x. Square root of 36 is x. Square root of x squared is x. And the 6x also goes here. And you've got a similar job here. 49y squared would be 7y. The 49 square roots to 7. The y squared square roots to y. So we have 6x minus 7y. One final stage of the difference of two squares is dealing with something even more complicated. Factorising something like this. Right, so I need to factorise 100x to the 8 minus 9y to the 12. Now there's no problem square rooting 109. That square roots to 10, that square roots to 3. But how do I square root the x to the 8? Square root of x to the 8. Square root of y to the 12. We don't leave it like that. That's the short answer. How do we do that? Do you want to maybe pause the video and just have a think before I reveal how it works? Do you want to play around, maybe write something down? Could you think what the square root of x to the 8 is and why? So let me tell you. When you square root something, what does it mean? I need something, when I times it by itself, it would give me what's inside the square root. So for example, when I square root 25, we know the answer is 5. Why is the answer 5? Because when I multiply 5 by itself, I get 25. That's essentially what a square root is. So, in answer to my question, if I want to square root x to the 8, what times is by itself to give me x to the 8? It's algebra. What times by itself to give me x to the 8? So let's take a look. Okay, I need two things multiplied by itself to give me x to the 8. Can you think what it would be? Well, I'll give you a clue. It involves x. X, okay, x to the something, right? And remember, a square root, you're timesing by itself. So whatever's in this barrel, as it were, must be over here as well. So hopefully you can recognise that it would be x to the 4. Why? Because when you times a power term by another power term, remember from the laws of indices, you add the powers. So in other words, I'm really asking a question, what two powers can I add together, because of that times, to make 8? And it must be x to the 4. Now, over here we've got y to the 12. Again, what two powers can I times by each other to give me y to the 12? Because I'm timesing and the laws of indices say we add, it must be y to the 6. Okay, because when I do y to the 6 times itself, that's what I need to do, that's a square root. You add the powers, okay, and you end up with 12. But instead of going through this long process every time, okay, it's really quite annoying to draw this every single time, and you don't need to. If it helps you, by all means, go ahead and do it. But what we see here actually is there's a very quick way to come up with the answer. Okay, so we've established the square root of x to the 8 is x to the 4. The square root of y to the 12 is y to the 6. because I've seen now when I times that by itself I get x to the 8th, when I times that by itself I get y to the, and you can see this works. Okay, if you just add the powers, the basic laws of indices. Now, so what have we learned here? We've learned something quite impressive. We've learned that the square root of x to a power, all it does, well, what does that square root do? All it does is it halves the power. Look, square root of y to 12 is y, it halves the power. So instead of doing all of this, just recognise to myself the square, if I want to square root a number, that's easy. I know how to square root a number, it's just logic. If I want to square root x to a power, or y to the power, or any letter to a power, all the square root does is it chops the power in half. That's all it does. So let's go back to our question. Let's open up a couple of brackets. Okay, let's go. Square root of 100x to the 8th. Well, square root of 100 is 10. Let's put it there and there. And we've now said when you square root a power, x to the power something, it halves the power. So the square root of x to the 8th is x to the 4. Remember, whatever goes here must go here if you're dealing with the difference of two squares. Now let's do this one. Square root of 9, so I have a plus here and a minus here. Square root of 9 is 3, so I must have 3 here and 3 here. But I also, with the 3, I need to square root of y to the 12. And we said if you want to square root the power of a letter, you just half the power. Y to the 6 and y to the 6. And again, if you want to be super convinced that what I'm telling you is correct, have a check. If I multiply these together, what happens? Look, 10x to the 4, multiply by 10x to the 4. Right, we've done this with work on our indices before. 10 times 10 is 100. X to the 4 times x to the 4, we add the powers, is x to the 8. So you multiply these together, you get that. And you can do something similar when you multiply this and this together. So let's have a go at a few of these harder types. Right, so have a go at factorising each of these. Press pause, have a go on paper, and let's see if you get it right. Okay, then press play and mark what you've done. Let's see if you get these right. Again, these are the hardest types of difference of two squares at this level. Okay, let's see. What do you notice? They're all two terms separated by a minus, which means when we factorise it, we can apply the theory of the difference of two squares, which effectively is square rooting the left and the right, putting it in one bracket with a plus and one bracket with a minus. Quite straightforward. Okay? Now, when there's a number involved, it's very easy. There's no thought involved. We know how to square root 25, so I can stick a 5 there straight away and a 5 there straight away. I can then put a plus here and a minus here. Very nice. Now, square rooting x to the 10. Right? So we said when you're square rooting x to a power, we've now learned that you square root that effectively means you halve the power. So all that needs to go here is x to the 5, and all here goes is x to the 5. And you can see when you multiply x to the 5 by itself, you add the two 5s and you get 10. So square rooting comes down to halving the power. Okay? Now, let's go with this. Right, so here we've got two sets of powers. So we've seen before, if you've got two things multiplied together, you just do them separately and glue them together. So square rooting x to the 8 is half that, so that's x to the 4. Let's put that there and there. Square rooting y to the 18, again, will halve the power, which is now 9. But it's multiplied, so you just put it with it. Y to the 9. And that's the beginning of both brackets. Square rooting 1 doesn't get much easier than that. The square root of 1 is 1. So there's a plus 1 here and a minus 1 there. Now number 3 has got heavy terms on the left and the right. Again, it looks more horrible, but it's effectively the same. So 30, just do it bit by bit. Square root 36, 6 here and here. Next, x to the 8, square root that will half that power. X to the 4, exactly the same from there. X to the 4. Square rooting y to 24 will half that power. Okay, so 6x to the 4 y to the 12, 6x to the 4 y to the 12. Minus, we know that there'll be a plus here and a minus here. And now let's just launch our way through and square root all of them. So, square root of 49x to 16y to 10. So, 49, square root to 7. Let's put a 7 here and a 7 there. Square root x to 16 halves the power. to the 8. And finally, square root of y to the 10 halves the power, so that's y to the 5. Okay, I'll just put it here, but it's 6x to the 4y to the 12 plus 7x to the 8y to the 5, and then 6x to the 4y to the 12 minus 7x to the 8y to the 5.